draw data, you have to collect data collections. Takes a critical step for your model. So from that, system performance simulation. Okay, and we have the outputs. Outputs we focus on the second half of our semester. It means after the midterm exam, and also performance simulation. And in order to underline for you, you need to collect it data. I mean accuracy appropriately and to present the environment. Now, the role of input is very important. Okay, you need to plan ahead. What should we do? We correct, we adjust the methods of collection. After that, you analyze data to see the trends, accuracy or not, adequate or not, and many other steps. Okay, beware of data censoring. Okay, and among variable, you need to check the relationship. You can figure out by drawing, scattering. Okay, auto correlation. You see independent or not. Okay, auto correlations. Okay, independent or not is the property of random number. One of the property you did it before. That's why we learned in the past about characteristics of data. So you collect data, not performance data. This is very critical. Collect data, not performance data. Performance data is the results of the real system, as same as your model outputs, not the input data. Hello, now we focus on input data. Okay, not performance data. For example, arrival rate, processing time. There are inputs, not the queue. The length of the queue, number of identity in the queue, that is the performance. That is. Luckily for you who hear and listen to that. The next, you identify histogram in the queue quality management. You know histogram, and after that, you select the family of distribution, and you estimate the parameter of each distribution, probability distribution. Okay, and you need to test the goodness, and you fix the non-stationary process. This is very meaningful. Now, the first histogram, you can draw the chart like this. I think everyone familiar with this one. And you need to identify number of observations. How many times you observe, in which frequency. Okay, and you see the disperse. Okay, disperse. You know two figure in the distribution. Disperse. The more disperse it is, the more variant it is, and the focus, the means. Okay, so you see the disperse, and you success a number of interval. Is the square root of the sample size. Okay, square root of the sample size. Okay, just take the square root of the sample size. Sample size like number of replication. Anyhow, okay. Later we will focus on this. Square root of sample size. The square root of n. So for continuous data, you see the probability density function PDF. And for discrete data, for sure, we have PMF. If a few data, what should we do? We need to combine adjacent to next together, okay, to eliminate the rack appear in the. So with G3 figure, we can see, hey, the first one, you see, the first, the upper one, here, a lot of rack. If you combine adjacent cell, it looks like very close. And the last one seems to be good. Okay. So next, this is one of the first example. We observe the arrival rate. Hello. If you have any question, you need to ask right away, because I go very detailed. So in this table, you can see each periods on the left hand side, the column, and the right hand side, the frequency. How many arrival? Okay, for every 5 minutes. Why 5 minutes? We have to reason. So we figure out it here. So we have the data here. Okay, we need to test lifetime performance of one sample, the lifetime. How long does it last? Okay, and we have 100 number here. 100 number here. We run it. Okay, here on the right hand side. So you this set of data, we have to identify the distribution. Yes, so you apply set distribution for your model. Input of your model, arena or anything. Okay, so let's see. On declare here. So you see, the interval, the width of 3. So now we figure out like that. The first interval, the second interval, etc. We figure out, oh, it looks like some kind of distribution. Can anyone tell us in the current what is the distribution? What should be the distribution of this graph? Hello? Anyone? What could be the distribution of this one? If you see the set, what should be the distribution? Yes.
Please. I think this exponential distribution, sir.
Yeah. Why? Say your name, please.
My name is Liu Yin, sir.
Yeah, Liu Yin. Yes. Why?
I think the shape is quite.
The shape, yeah. Liu Yin, very good. Anyone else agree with Liu Yin? Hello. Vũ Liễu Uyên, right?
Yes, sir.
Hello, student. Anyone else? Agree? Liễu Uyên say exponential. Yes. Why? First, the set. Yes. Thank you, Uyên. You have a bonus. Okay. Oh, you have many bonus already. In the theories and in the lab also. Hello, Uyên. Oh, great. Yes.
How can we apply that bonus? I really don't know.
No, never mind. In the midterm exam.
Okay,
Are
sir.
you worry that you have the
I
maximum
don't-
midterm exam already?
I think
And
that
how?
we will use it in our in class performance. So I don't know. Just raise my hand and answer something.
Yeah. Okay, good. You know that, for example, you have 10 bonus and your midterm exam is, 2 parts. Huh? So actually it's in the progress also. Okay, don't worry about that. Lab for lab, theory is theory. You have many bonus. Okay, very good.
Yes, sir.
So very easy like that. And you see the nature, the context. Okay, right. Okay, in the fifth term. Okay, exponential or Poisson. Inverse of Poisson is exponential. Okay, so we need to check something like it. Let's see what else. Okay. Okay, so with that, you can see here. Oh, frequencies. You need to identify, select the family of the distributions, family context, of the input variable and the set. Okay. You know the theory in detail. Later on, you can apply many software or you can code to identify and recommend the distribution. But now we just focus on theory basically. So again, Liễu Uyên just say, Uyên, the set, right? Right? Uyên, you may on the set. Okay.
Yes.
Okay.
Yes, sir.
Yeah, just so very, very normal. Okay. And you can see how often you use some kind of distribution. For example, easy because the set look different. Or exponential, normal, and Poissons. Okay, especially 2, 3 more is equal. Okay. Yes. So the basic, the physical basics. Physical basics. This line is very important. Okay, it presents the physical basis case by case. For example, binomial. You want to identify the number of success in an trial. Okay, it's the nature. Okay, the context. Yeah, the context here. The context here. Okay, We call it physical basis. Okay, the Poisson independent event occur in fixed space amount of time. In arena, you apply a lot of time, right? Yến Nhi, hello. Văn Minh, hello Văn
Yes,
Minh.
sir.
Yes, I hear your voice. Văn Minh, in the
Yes.
last section, you keep asking the good question. Why not in the theory section? Văn Minh.
I just don't have question.
But any comment? Yes, keep going on. You know that we appreciate your attitudes. Okay?
Yes.
Yeah, very good, Min. Yeah. So you can see, actually, a person, huh? I say many times, in the fixed amount of time or space. So, what does it mean? Liễu, Uyên, you can see there. Okay, actually, the distribution we should recommend in the previous case, which I asked you. Uyên, E, Poisson. Hello, Uyên. Poisson, not exponential. Okay.
Reverse case Poisson, sir.
Yeah. Okay, because
How
it's
can we distinguish those two distributions?
Come again.
How can we distinguish the two distribution? Because I see that the same is quite the same. They have similarities, so
Yeah.
it's quite hard to distinguish.
Yeah. Distinguish. You know, every distribution has a function. Okay, lambda. Hello, have a parameter. And how about the function? Okay, Ian, based on the functions and the set based on the function. Okay, that is. Ian, hello,
Okay.
Ian. Yeah, based on the function. Y
Reverse
equal
case
to AX plus B. It's a linear. Okay. So
Okay,
1 over lambda is an inverse. Okay.
Okay, sir.
Yeah. Okay. Thank you very much. So you can see, the event, but independent. You know, the previous vehicle and the next vehicle independent. Okay, independent, right? So vehicle arrival is an event. So it occurs in a fixed amount of time. Every 5 minutes. You can see here. Every 5 minutes. Okay. Every 5 minutes. Okay. So every 5 minutes. Okay. It occurs here. Okay. Yeah. So we figure out like this. Now again, a space area. For example, you take a sample. Every 1,000 bottle drinking water. Okay, bottle. 1,000 bottle. You take 5 samples. Okay, etc. So the probability of the defect events of the defect item occur in 1,000 space. Yeah? Maybe 1,000 bottle, maybe 1 cubic meter etc. So this slide very important. The next, normal, is so famous. So they call normal distribution. Okay, so a sum of number of component of process. For example, you want to check the length of your ruler. Okay, it's normally follow the normal distribution. Okay, the volume of drinking water also. Processing time of some step also. So normal. One by one, exponential, the time between independent event. This event happen, another event happen, and time between two customer arrive. Time, huh? Not number of customer. Hello, student in the class, especially Liu Yuen. Now, time between two customer, the first customer and the second customer, it follow exponential. Okay, not number of customer. If number of customer arrival in 1 minute, it follow Poisson. Okay. So next, number 5. The time to failure of a component. For example, your laptop, PC, time to failure. Normally they follow this one. Okay, your machine failure, time to failure. Okay. Another continuous uniform. Minimum, maximum. Next, triangular, minimum, maximum, and in the between is most likely. Very possible it happen in the most likely. You can convert it into the normal distribution anyhow. And the last but not least, empirical. It's your data. And you also can apply it directly in Arena. Hello, Arena. Just for example, schedule. Okay, how often they arrive? Just right and out. Processing time, yet you collect the first, the second, the third, etc. You just put it into Arena. Okay, so remember physical characteristic of the process. Okay, based on the nature of the process. Okay, the nature of the process. Okay, here naturally decrease. Remember, hello, Trang, are you there? Hello, Trang. Nguyễn Tuấn, you know, I need to check if any of you over there. I need to check also value, and nobody answer. Value ranks only positive or negative. Okay, you have the limit or not? Okay. A limit or not? What does it mean in the limit? For example, you observe our student graduate from our school. Okay, the minimum might be 3 years. After 3 years, they graduate. The maximum, we don't know. But we have to identify the maximum. Maybe 6 years. The bow. Why? There might be administrative requirements. It's number of years. Okay. So next, physical characteristic of the process. You need to know such kind of things. I just go through the previous slide, show you many things. Okay. Okay. So now, because in the reality, especially for the stochastics, okay, they conclude no two distribution for any stochastic input process. No two, okay, actually two. Okay. So you approximate. Hello. You need to figure out the method to collect, to identify, to prove it within acceptable. It means good, acceptable value. Okay. Now, this is the content for not only let's see academy, but very useful. Okay. So to identify the distribution, we will quantile plot QQ. So in order to evaluate the distributions, it fit or not. So in this case, the random X comes with the CDF. Then we can figure out the Q and Q. For example, here we have a functions. Let's see. Function here. Follow here. Okay. Easy. Okay. So when we add, we have the inverse. So we can identify A stop. So let's see the procedure. The procedure is here. Okay. So sample data from X, and let's see it is the observation. We put in the ascending order. So we have S and YJs approximate to this value, and we rank J is the rankings or the number. Yeah. So we see Q and Q. So we have approximate the state line. If F is the member of the appropriate family of distribution. Next, the line has the slope is 1. Oh, it's very good. Not only the member of a family, but also it have the appropriate parameter value. That is the principle. Now we can see one example here. Okay, we have list of data. You know, we check open, close, open, close, open, close in order to install a door. You have a door. The time to install, it might be in minutes. Okay, you need a measure in minutes. So you see, we have how many observations here? Hello. Xuân Thịnh. Hello Thịnh. Are you there? Thịnh. When I call your name, no answer. It means you have a minus. Hello? How many observations are there? Okay, let's see. Okay. Plot such value, you rank in the order. Okay, you rank in the order here. And you see, apply this one. We have normal distribution. This one. Normal distribution, you have the mean, means, and the variance. This is one. Okay, so you have standard deviations, the square root of this one. Okay, so we see for this, we identify the distribution by applying the Q and Q plot. Oh, Q and Q plot, you can see both. Oh, you plot it out here. Yeah, and you also see it look like the normal distribution. Study. Okay, many examples. Also here, you can see further analysis. Okay, observation value never found exactly on the straight line. Okay, like in the QC. Okay, you have control line, upper, lower, upper, upper, lower, lower, control, and the mean. And you plot it. It's seldom rough in the straight line. And the order of value rank and hand not independent. Okay, this one is very important. Okay, variance of the extreme. Extreme it means far left or far right. Okay, it's higher than, you can see this one. Okay, it's higher than at the middle. At the middle, it nearly close. Okay, and linearity of the point of middle point is more important. It looks like linearly in this square, circle. Okay, okay, from this plate to this plate, it look like a linear. It's fixed. It means it's fixed. So Q and Q. Okay, Q and Q. You can check for this one, and we plot it again. So we go through this one. Another example. I wonder. Example. Now we estimate the parameter. Hello, student. This is a technique. It's not difficult for you at all. You studied it before. Now just apply. Now we already know the family of distribution. So in the distribution, we have parameter. Maybe 1, maybe 2, maybe 3 parameter. Okay. So we need to identify the value of parameter. Just estimate. Okay. So normally we know the sample means and variance. So far we just have a sample because we collect data. Okay, we collect data and we need to identify First, the distribution. Second, in the distribution, we need to identify parameter. So the formula here, okay, for the mean and for the variance. Okay, let me check. Okay, on the left hand side and the right hand side, respectively. And if it is district and we have been grouped in the frequency of distribution also over there, the formula for you. So Fj is of the frequency of value. Okay. Next, from search draw data. If we don't see any data means for your model, so we approximate a sample mean and variance by this one. The third formula we need to know in order to identify estimate parameter. Okay, and you know that conclusion parameter is an unknown constant. Parameter is constant, but when you estimate, it is a static. Okay, so now go to example. Okay, an example before. Okay, in slide number 8. Slide number 8, you remember here we have here. Okay, we have data. You collect arrival of vehicle in one corner in every 5 minutes. So number 9. Okay, so we know 100 observations. And from that we can identify the means and the standard deviations, because we have variance here. Okay, so what should we do? Next. We see it is a Poisson's distribution. What should we do? So we see sample mean is not equal to sample variance. Reason the estimator is a random number. Okay. Yes. Next, many examples over there in the textbook for exponential, for variable, for Poisson, for log normal, for gamma, and for beta. In the textbook, many examples. We go through some examples. Before that, I would to share. Now, if you already identify the distribution and parameter, you need to check that here to check if fit or not. Goodness of fit. Okay, so we need to conduct the hypothesis test. And luckily, we already know first hypothesis test And the method, the KS, remember property of random number, and chi-square. Okay. For first case. Okay. For the second case, if no single correct distributions in the real case. So this is pick up thing. If very little data available, it's likely to reject all candidate. Okay. You see, if you have a little data, you tends to keep all distribution. Okay, so very hard for you to reject. Okay, and in another hand, if you have a lot of data, you have many options, so it's very likely for you to reject all the candidates distributions. So what should be enough? What should be enough? So take more sample is good because it represents, but the time, resource, and also this is one applied to most of the things. Okay, in your life, if you have many options, okay, you likely to reject the suitable option for you. Okay, let's see. KS, chi-square. Chi-square, the methods. You know chi-square test already, right? Right? Kiều Yến. Hello. Kiều Châu Phi Yến. Hello, Kiều Châu Phi Yến.
Yes,
Are you
teacher.
there? Did you hear my questions?
Can you repeat?
Okay. Did you use chi-square text before? Did you?
Yes.
Yes. Okay. Lovely. You know how to apply this one to identify chi-square value here. Observe frequency, active frequent, etc. Here. Did you? Don't worry, just say yes or no. Hello. If you did it before, just say that. If no, just say no. Yeah. Hello.
I think I did it in probabilities.
Yeah, very good. Very good. Yes, very good. Yes. All in that course and apply it here. Okay, it's very meaningful. Thank you. Yeah. Yeah. So hello student in the class. Hey, the intentions. Huh? The intentions. Intention in this case. Compare the histogram of data to the set of the candidates. Huh? Either CDF or CMF. Okay. Okay. It means district or continuous. Okay. So it's used for big sample size. Rank and observation into K class. Here, approximated here. Chi-square distribution. And remember, chi-square distribution, K, S, minus 1. What is k? What is s? S is number of parameter. If for example, Poisson's are exponential, so s will be 1. For normal, s will be 2, mu and sigma. Okay, and so far, Uyên Tôn, are you there? Uyên, Tôn, Uyên, hello, hello Tôn, nữ Minh Uyên, hello, anyone can tell?
Yes.
Yeah, how are you?
I'm good.
Good. So in the triangular distribution, what is the value of x? You see in the slide here, what is the value of x? In case of triangular distribution. Hello?
I think this is 3.
Yes, very good. Okay, why? Maybe very easy for you, but I would like to ask why for you to explain to our class. Yeah, good. Hello.
Because for a triangle distribution, we always have the lower, the middle, and the upper value.
Yes. Perfect, huh? Thank you. You have a bonus. Phạm Tuấn Phát. Hello, are you there? Hello, Pháp. Phạm Tuấn Phát. No. Second time, no. Okay. So, K, you know the K, right? K class. Okay. So, you look in the table. See it. So, what else? Next, we go to chi-square test. Here. A null hypothesis. It's conformed to the assumptions of the distribution. You assume it's conformed to such distribution and parameter. Okay, and another hypothesis is it does not confirm. Okay, so if the distribution test is decreed or combined as a assumption, it's not required. Okay, so we can see here, its value of random variable should be a flat interval, unless combining is necessary. So you see here, one example. In such case, if we think it is continuous, we follow this one. We recommend number of class interval here. Okay, so example. This is a recommendation. Hello, student. Okay, if the sample size, too small, don't use the chi-square test. Okay. Yes, at least this one aside. And they recommend the value of k. Okay, value of k class. Okay. Yeah, this is k. This is a basic table. Okay. Next, you take such kind of data into this graph, and now we apply. Huh? Oh, it follow Poisson just statement. This one not Poisson. So if this one we reject it. Let's see. Okay, we put it here. And you see, hello student, this is the key thing. One of the key things here. You see, oh, it's near together. It should combine with each other. Also here. But the second, we calculate the expected value in terms of frequency. So you can see, why? Because of the minimum expected value. Yeah. Okay. Yeah. So this one. Okay. Okay. And also this one. So degree of freedom. You know why? You know one why you have 7? Hello. In this slide, why do we have 7 here? Anyone can answer me? Huh? Hello, student in class. Why do we have number 7 here? Nguyễn Phi Long.
Yes, teacher.
Why do we have?
It's the combine of 1, 2, 3, 4, 5, 6, 7, and the arrow.
Come on, long. Good student. Long. Come on. Later on, you process your data. Long. Very important.
Yes.
Long. Not only how can I say, not only in the exam, okay, but also in the reality. Long.
Yes, teacher.
Okay. Anyone else can answer why we have number 7 here? Okay. Hello. Yes. Go ahead.
Yes. Because I think in the expected frequencies, we have a seven number that's grouped.
Yeah.
That is a 2.6, 9.6 is a 2, and the 5 1 below. So we have 7 number that's sum
1, right?
7. Yes.
Right. 1, right? And after that?
9.6 is a 2.
Yes.
And
no.
4.
9.6 and you combine 2.6, 9.6 is 1, right?
Yeah. And yes, and the below.
Yeah. 2.
4.4.
Yeah. 2. Okay.
Yes.
So let me. Hello, student. The first here. Okay. We have 1, right? Right. The first one, right? The second is 2, 3, 4, 5, 6, right? 2 to 6, right? Hello, Phước.
Yes.
Yes, right. And this one is 7.
Yes.
Is that clear? Hello, student in class. Thank you very much, Phước. Yeah, you always answer correct. Especially last week, you have 2 bonus. And this week, you have 1. Okay. Nguyễn Văn Phước. Okay.
Thank you, teacher.
How about you? Yes. I have a chance for everyone. Okay. So that's why we have here. Okay. And you see, the hypothesis is rejected at this level of significance. Okay. Because chi-square too big. Okay. What else? You can see also degree of freedom. I explained in this case. Okay. 1, 2, 3, 4, 5, 6. Observe frequency here. So because of this, chi-square too big versus what value in the table is 11.1. So we reject at the significance level of 0.05. Next, I also detail it here how we have such number. Okay, the calculation, many things here. Okay, and example here. Now KS. Hello, student. KS. KS. Also, a tool, a techniques to test the goodness of fish. Okay, so when the sample is more small, no parameter had estimate. Okay, and you remember open book, so we know the table here. Okay, you need such table to identify the number. The KS test, we know because you know we apply it many times in previous course called statistics and probability, and we apply it in the second week of this course for KS and chi-square. So I just go through very fast. Okay, because you have homework already. The same, for example, this one, the method. So you can identify this one. Okay. Oh, you put it in here. You see, if we have 5 number, okay, you know, small, right? Small sample size. Okay, we cannot apply chi-square. Okay, at least 20. Okay, so step by step, random from small to the large. Step 2, like that. Okay, you identify D plus, D minus. You write it here. And step you need to identify with the alpha how much for the alpha. Okay, and you compare. You say based on this result. Okay, you compare the alpha versus the max. Yeah, the alpha. Oh, it means it allow bigger variance. So because the max is 0.26 when the alpha is bigger, so we not reject. Okay, So many example like this. You can do it in your homework. Now we go to the p-value and the bad fit. Good fit. P-value. Smaller p-value, bad fit. You know p-value already? Okay. San. Hello, San. Are you there?
Yes.
San. P-value is familiar with you or not?
Yes.
Okay. So bigger p-value better. Smaller p-value better.
Can you repeat?
Bigger p-value better or smaller p-value better?
Bigger p-value is better.
Why?
Because the bigger p-value, the higher percentage. So I think it is better.
Higher percentage of what? Rejection or acceptance?
Bigger percentage of acceptance, I think.
Yes. So thank you very much. So when they ask you better, common sense, better in terms of what? Okay. Better in terms of convenience or cost. Okay. Etc. Okay. Thank you very much. Anyhow, you have a good question, answer. So we go through one example here. Example in the slide number 9. And we see and we apply the p-value to reject within the significant level. So in such case, we see poor fits or poisons in this example. Okay. So p-value and bad fit again. Nowadays many things, but it's not. You always inspect in order to do so. This step is very important. Hello, student. If you have any data and you need to fit the non-stationary Poisson process, you should apply it. And I prefer you read it first. Okay? You read it first. Okay? Hello, student. You read it first. Let me see, figure out. Okay, let me see. Figure out. Hello. Accept it, reject it. What is that? So noisy. Sorry, echo. To mute and unmute again. I don't know why. Let's see. How? So maybe two equipment too near together. Let's see. See this. Okay. So accepted, rejected, number of run modeling of. Let's see. Hello student, let me show you in Arena. Did you see my string clearly? Did you answer directly, please? In Arena? Hello student. Sam, are you there?
Yes,
Did you hear me clearly?
yes, it's clear.
Thank you. Very simple like that. In Arena, you see my strings. You go to Tools, Inputs, Analyzer. For example, you have a set of data. Let me see the set of data. You put it something. Let me check at the beginning. Okay. Let me see. You see, for example, the okay, that's this one. Okay, you say you have something. Okay, you have an input data here, and you want to apply, and you see. Did you see my string clearly, Sam?
Yes.
Did you see this
Yes.
one? What is the value of number
Oh,
of?
no. I don't see
No?
the input analyzer.
Okay.
Yeah, so you should share the screen.
Yeah. Thank you. That's why I asked. Okay. This one. Did you see it? Hello.
Yes.
Did you see it?
Yes.
Okay. You see from set of data, we can filter out here, and you can click. Very simple. It fit all. You use existing data. Any data you have. For example, here you see it is a uniform, and you can see here. Hello, student. Number of interval. If you think it's a uniform, you click on the uniform, and to do so, they show you chi-square test. Hello, Ian or Sam, did you see the chi-square test here? Did you see?
Yes.
Okay, I think that because okay, you can see corresponding p-value. Not too small. Okay, and KS test corresponding p-value also. Oh, you summarize it here. It's for all. Okay, so the first, the second, if let's see, this one, let's see, you fit all. Okay, you fit all. Okay, it recommend you the best is this one. What you see? Hello, student. For the inputs, we study in theory, and now I show you the way some software, such as Arena, can help you. But you need to know the number first. Corresponding value, how much? Okay, you accept or not? Hello, last time corresponding is 0.5. 0.05. Now for beta E over O1. Okay, that's statistic here. Do you accept or not? You can see. Hello, student. Take a look in the current one. Maybe I need too much. What just said. You can see they summarize all. If it follow beta, what is square error? The smaller square error is better. It's one of the things. What should we do? So in this series of data, what should we do? What distribution you should select? Huh? Hello? Hello. You can see list of 1, 2, 3, 4, 5, 6, 7, 8, 9. Recommend distributions. Okay? Huh? What should we do? Hello, student. In this case, what should we do? We accept beta or wearable? Huh? Or not? Huh? Any idea? Any idea? For example, I select gamma. Okay? What should we do? You see this one? Hello, student? Or you want to take a break? How can I ask many questions and no answer? Hello, student? Hello?
Yes.
Yes, what do you mean, yes?
Okay, you can continue.
Continue, okay. Continue, okay. You see in the screen. Hello, you know, in Arena, you go through such kind of tool to select the input analyzer, process analyzer, many things else. Okay, but today we talk about inputs. So I show you one example of the inputs. You can select any series of data according to the format. You put in the right format. Okay. Yeah. Okay. Let's see. Okay. And now we want to check. Okay. Want to check. Oh, beautiful. Okay. It figure out for you. Okay. All of the thing here. Okay. If you want to check like normal. Okay. Oh, it's figure out. Also here, normal value correspondence for KX, S, etc. Okay. So, what else? You can use it. You can see insert. They have chi-square test and KS test. Okay. I have one question for you. If we fit all, okay? If we fit all, try to fit all, okay? Try to fit all summary, okay? We have this one. So what should we do? What should we do? Okay. What should we do? You select the one with smallest error. What are criteria that you apply to select the appropriate distribution according to a series of your data? Tuyên, are you there?
Yes.
You see in the screen now. You accept beta distribution or not? If not, why? If yes, also, what is the reason?
I think I will accept beta because it said the corresponding p-value from the test is less than alpha.
Yeah, good. What else? What
else? And it also had small square error.
Yeah, good. Small. How small is small? Okay. Okay. Yeah, good. What else? What else? Hello, student. What else? Tuyên, you have a good answer.
I cannot think of any other answer.
You need 5 more minutes or no? I think it's easy for you. Tuyên, I think it's easy for you.
Okay, so can you give me a hint or something?
A hint, huh? A hint. You know, to select or reject, we need to base on the technique. Okay? And criteria. You know criteria? Okay? Criteria. Muốn đánh giá chấp nhận hay không chấp nhận thì có hypothesis test, nhưng mà mình phải có tiêu chí, đúng không? Đúng không?
Yeah.
Thì tiêu chí là gì đây? Thầy hỏi cả lớp đấy. Alo. Tiêu chí là gì? Nghĩ ra coi. Tiêu chí là gì? Ví dụ đây. Beta, small error, yes. Variable. Cũng em thấy, các em thấy nè, từ normal nè cho tới các cái khác nè, đây nè, thì square error gần như giống nhau. Ok, yeah. Nhóm này này gần như giống nhau, thì đương nhiên square error là một tiêu chí. Yeah. Good. Set. Good. What else? Physics. Condition. Context. What else? There are about 5 criteria, so you can accept. And criteria, you also put a priority. You apply with priority first. Okay. Trần Thanh Kim Thủy. Hello Thủy.
Yes, sir.
Can you hear me?
Yes.
Yes. So, what is your recommendation?
I don't know.
Okay, you need 5 more minutes. Do you?
I don't know.
I just say already 4 criteria. What is the last criteria? Hello, student in the class. Square error, smallest first. Okay. The second, the nature of the process. The third, the set. And what else? For example, in this case, okay, compare the p-value, the 4. What is the last one? I have 5 minutes for you, or 3 minutes. What do you think?
Teacher, is that the histogram?
Yes, histogram is wrap. Same.
Oh, okay.
Okay. Vương, hello. Who just say? Thủy or Vương? Say your name, please. Who just say? Thủy.
It
Yeah.
was Minh Uyên. No. It was Tôn Nữ Minh Uyên or something.
Really? Uyên? Okay. Uyên. Okay. You have many bonus also. So, what should we do? To select or to reject, we need criteria. Okay. Based on criteria, we also need to prioritize which is the first priority. Okay. So many things. Arena, many other software also can. Okay. Many other software also. You can code for your selection process also. Okay, take a break. Who can answer additional criteria? Don't worry wrong or right. Okay, just think. Okay, we have a big bonus. Okay, take a break for 5 minutes. After that, I think we review for such example and midterm exam also. Thank you. Hello, student. Try, come on. No, it's good. Okay. If you follow and you think, okay, it's logic. So we start. Do you have any answer? Lê Trần Ánh Sáng. Hello.
Yes, teacher.
Do you have any answer?
Sorry, I have no answer.
Do you have any idea?
Just no, teacher.
To be honest, do you know what is the question? Do you know what is the question? What are the criteria? Hello, student. Huh? Any criteria? I list. Huh? 4 criteria already. Now last criteria. Okay? But nobody answer. Huh? What should be the answer? Hello. You have a big bonus if you can realize the one criteria, additional criteria. Okay, what do you think? Hello. In zoo distribution have the fewer parameter, you should select it. Sam, did you hear me clearly? Sam.
Yes, I hear you.
Can you repeat what I just said?
Sorry, can you repeat?
Oh, no. Trần Thanh Kim Thủy, are you there?
Yes, sir.
Did you hear what I just said?
What you just asked? What are the criteria to select the distribution?
Yes.
Yeah.
What
And
were...
you asked what is the fifth criteria?
Yes, the fifth. What I just said.
I didn't hear.
Oh, wonderful. I don't know why. Okay, wonderful. You set in priority. Okay. Okay. And the last one. The last criteria. Okay. Is that distribution have a fewer the least parameter. Right? Sam, can you hear me?
Yes.
Sam, hello Sam.
Yes, I hear you.
The fewest, the least parameter. Okay.
Yes.
More accuracy. Among
Yes.
many distribution meets you first 4 criteria. And if we have some candidate miss all other criteria, so you should select the distribution have fewer parameter. Okay, so Now, time to review for midterm exam. Are you ready? Hello, if you are ready. If you are ready, send a chat. This time, I would like to ask, if you are ready, just chat. And say yes. Okay, chat and say that. You Kim Khánh, who else? Because after 2 minutes, I will block the chat. Okay, good. Now I would like to share a little exam. Okay. Call your friends, come. Okay, thank you very much. Now, what else? You see in the slide clearly? One,
Yes,
two, three,
teacher.
4, 5, 6, 7, 8. Oh, okay. Okay, very good. So, in theory, about these questions, to focus on statistics of model validation, random number, and variate. Okay. What else? So, for example, we have a list. For such simulation can be used as blah blah blah. You max the option. Okay. So, can anyone help me for the first? For the first one, you select A, B, C, D, E, or A.
B, teacher.
B. Who is that?
My name is Khánh.
Khánh. Okay. Why? Good. Khánh. Khánh.
Yes.
Why? What is the reason you select?
Well, it's because, well, if we're talking about the grammar, it is the only answer that fits the grammar in that sentence. And it also the meaning of simulation.
Oh, okay. Good. Okay. Thank you very much. A. 1A. Okay. 1B. Did you see it before? So next. You see it, right? What is the answer for question for number 2? Can you have a bonus again? Hello, Khánh.
Thank you, teacher.
Yeah, you have several. Yeah, welcome. So, hello, student. For B, for number 2, what should be?
May I try, sir?
Yeah, go ahead. Why not? Huh?
I think that 2 is matched with the letter D. Simulation cannot be used to provide descriptive analysis despite inefficient data inputs.
Mm-hmm. Why? A little bit, just a little bit. Why?
Because as you can see, the meaning is said on well, simulation cannot use inefficient data to analyze anything. I think.
Oh, you have a yes. Okay. So in such case of descriptive analysis and effective data inputs. Yes. Okay. Thank you very much. Ian, again. Right. How can today you have 3 voters?
Okay.
Okay. Okay. So let's see. Also for search matchings. Let me see how to share such kind of things. You know, later one by one. I would like to share that. Share window.
So I would like to notice that I am Liu Ying. I'm not Nguyen. So
Vũ Liễu Uyên, right?
yes, sir. Because Miss Nguyen text me and she that you don't recognize me.
Dạ Duy Uyên, tôn nữ Minh Uyên, Võ Mỹ Uyên, and you?
Yes, sir.
You are Võ Mỹ Uyên?
No, I'm not.
No.
Vũ Liễu Uyên, sir. Yes.
You are
Vũ Liễu Uyên, sir.
Vũ Liễu Uyên, the student ID and with 92, right?
Yes, sir. Yeah.
You're so careful. I'm much more careful than you. Okay.
Thank you, sir.
Okay. So, do you see my screen now? Oh.
No, teacher.
Not yet, right? Hey. Oh, that's the another one. I just show you my record. Okay. Now show you another match. Another matchings. The matchings. Okay. So. Okay. Hello, student. For example, hey, you have 2 kind of tests, chi-square and ks, geometric. You have some attribute, okay? Some attribute, geometric. Which one? For example, you go for chi-test, okay, and you put geometric on the right hand side to the left hand side. Is that okay? Vũ Đình Long.
Yes, teacher.
Is that clear for you? Some
yes.
Example like this. Okay, so you match left and the right. Okay, you fill in. Okay.
Yes.
Oh, echo. So approximate exact because of attribute of its kind of text. Okay, so you put it in this order. Okay, for example, put it here. So this one. Okay, container cell size fluent components. Okay, any other question? Do you have any other questions? Just let me know. Okay. So, sorry. Anyone want to try? Anyone want to try? For example, number 9, number 5 here. Anyone want or not? If not, speak directly, please.
Yes, teacher. May I try?
Yes.
Number 5. I think number
Say
5.
your name, please.
Food. Yes. My name is Food.
Phước. Okay, Phước. Yes, number 5. Phước.
Number 5 is C.
Number C. Include visualizing operation. Yes.
Yes.
Phước. Do you want to try more? Try?
No.
C. Correct. Correct, Phước. You have additional bonus. Okay?
Yes, thank you, teacher.
Anyone else want to try? Try Phước. Try Uyên. Okay? Otherwise, we go to the next. Okay. We have let me see. We have a spreadsheet. Actually, you can write down. No need in the Excel. Okay, you write down because there will be a outline. So everything you write in the paper sheet. Okay. In this case, you buy a newspaper. The price is 35 cents. Hello? And sell the 55 cents. Okay? If at the end of the day, there are some newspaper, you can sell the service value of 10 cents each. So the condition is that you need to buy in bulk 10 stock. Okay, and this is very important. 2 types of new day, good and poor, with the probability of 0.45 and 0.55. So old. Okay. So if the seller want to purchase 70 newspaper a day, so you need to build a simulation table. We called the manual simulation to see the profits at this day. Okay. For sure, we need the random number. For example, in this case, we have random number divided in 2 rows. The first row and the second row. For example, here. Okay. So we have also the table. Oh, the demand will be here with the probability in case of good and in case of poor in the 2 next columns. Okay, do you have any idea? Duy? Hello, Duy.
Yes, sir.
Do you have any idea to develop a table for manual simulation? Duy? Huh? Duy? Do you have any idea?
I have no idea, sir.
Oh, next week we have exam. Any student have any idea? Nguyễn Thế Nam. Hello, Nam. Hello, Nam. Okay. Quỳnh. Hello, Quỳnh. Who is Quỳnh? Quỳnh Phạm. Hello. Hello, Quỳnh Phạm. Okay. Thanh Trúc.
Yes, sir.
Do you have any idea, Trúc?
Not yet, sir. I'm thinking.
Why? Trúc. Diệp Trần Anh Tú. Hello, Tú.
Yes, sir.
Do you have any idea?
I'm still thinking, sir.
Thinking of what? First data. What are steps to do so? Tú. Tú. Huh?
Yes, sir. Can you show me how to do it? Because I still have not reviewed.
Okay, you are very honest. Very good. Okay. Do your best. Okay. Hello, student in class. It should be easy, very easy if you did your homework. Now we have 2 sets of random number. The first random number and the second random number. Okay, so we have to figure out here. Okay, you remember this data for your model. Okay, so you can see. Okay, You use random number. The first come here. Right? The first. You see 0.11, 0.04. Okay? The first come here. And the second array of random number come here. Come here. The second come here. Okay? 2. Are you following?
Yes, I'm still following.
Okay, good. Huh? So next, what should we do? Okay, come here. Okay. So how to identify it a good or poor date? Okay, because it depends on good or poor date. You can identify the demand of that date, right? And in order to have the demand, to identify the profits by this formula. Okay, so what should we do? Hello, student. What should we do? I showed you, huh? In this case, Nguyễn Hữu Long. Do you have any idea? Long?
No, sir.
No. Okay. Any idea to identify poor and good date? Okay. Poor and good date. Poor and good date. How? Any idea? Vân San, Hoàng Phúc, Minh Tâm. Hello, Tâm. Tâm. See that. Hoàng Phúc, Minh Tâm. Tâm. Call your name many times. Yes.
Teacher, can I answer this?
Yes, sure.
I think that we will base on the lost profit in lost profit.
Oui. Yes. And then
We will base on lost profit from excess demand.
Yeah.
Yes.
Okay, good.
And we can define what is the pool.
No. Not three, right? Three.
Yes.
Okay. Actually, the process is different. Okay. Never mind. At least you have an idea. Okay. let me show you. Okay. Hey. Hello, student. Hồng Nhung. Hello, Hồng Nhung. Nhung. Hồng Nhung. No idea. I called your name many times before. Hồng Nhung. Never mind. Yeah, it should be not difficult. Okay. Let me show you. Okay. Let me show you in detail. Okay. Hello, student in the class. Do you see my screen clearly? Hạnh. Hello, Hạnh. Nguyễn Minh Hạnh. Again, Hạnh. No answer, Han. I just ask, do you see my screen clearly or not? Okay. Hello, student. So you see the first random number here, okay? The second random number, you leave it here, okay? And you see the goods, 45%, right? The poor, 55%. So you first, hello student, the first, you tabulate this table. Can you hear me clearly? Nguyễn Hùng Long. Hello. Kim Khánh. Khánh, can you hear me clearly?
Yes, teacher.
Okay. What did I say? Don't worry, right or wrong.
You saying about random number.
Random number, yes. And what else? The first, you tabulate this table. Can. Okay, good. You can see good here. 45% poor here. So, hey, this random number we put here, okay? In this table, we have type of new days, probability, cumulate until 1, and this is the most important. If it happens from over 0 to 0.45, it falls in this one, right? Hello, Khanh, are you following?
Yes, teacher.
Okay, okay, very good. It is in this rank, okay? Okay, in this rank, okay? It will be fall in the poor, okay? And by all, the poor or the good, with additional random number, we will know, the demand. Okay, Huy? Hello, Huy. Do you follow?
Yes, sir.
Okay, now it's clear or not?
Yes, clear.
Okay.
I thought that
Okay.
that